Far away from Earth, Saturn is orbited by the most complex and mysterious satellite in the solar system. But what makes Titan such a unique celestial body in our solar system? Why did it draw so much attention to itself? The amount of incredible features on this satellite deserves its own documentary. Our video today will touch upon Titan's unique atmosphere, liquid present at the surface, a very Earth-like landscape, an ocean of warm water, rains that would take your breath away, and finally, a life form that not everyone will be able to imagine. These mysteries compelled us to research the information available about Titan and try to fit it all into one video. This satellite, which resembles the young, cold Earth from the past from the scientific point of view, invites you to take a deep dive into its mysterious nature. Among 63 known moons of Saturn, Titan immediately stands out as the largest one. And it's truly gigantic. Its diameter is 3,200 miles. It's larger than Mercury and only a fraction smaller than Mars. Although its size allows any amateur astronomer to study Titan even without a professional-grade telescope, until recently it remained a major mystery. This moon was discovered in 1655 by astronomer Christian Huygens, who noticed an object moving alongside Saturn. It had been spotted before but was assumed to be a star. It was first visited by the Pioneer 11 probe and subsequently revisited by Voyager 1 and 2. However, these first images could tell very little about the satellite, but they already showcase something unusual. The haze that obscured Titan from the eyes of the scientist turned out to be layered, its top layer mainly composed of hydrogen and nitrogen. Further attempts to study Titan using the Hubble telescope weren't successful. Research was revived by renowned astrophysicist and promoter of planetary science, Carl Sagan. He was the one to suggest that if the temperature on the surface of Titan is negative 290 Fahrenheit, then the methane that turns liquid at that temperature could be spread across the entire surface, which would mean that Titan is the place to go if you want to see an ocean of methane. Anyone who uses a gas stove is familiar with methane as the gas we light for cooking. Now imagine a place where this gas became a liquid, where it falls from the sky in the form of rain, fills methane rivers, and where these rivers flow into gigantic methane seas. In 1997, the Cassini probe was sent to Saturn with a mission to study the planet itself as well as its satellites. Even though Titan wasn't the main focus of this journey, the Cassini probe included a special lander spacecraft, Huygens, that was launched toward Titan in 2004. And almost half of the data recorded in the process of its landing was lost. We have the opportunity to experience the journey to the surface of Titan. The descent took about 2.5 hours. The atmosphere on Titan turned out to be so dense that Huygens floated down with a parachute veered from its course and was spinning so fast that many images taken throughout the process were ruined. The journey down to the surface also revealed the extent of the atmosphere. Turns out, it reaches over 300 miles above the surface, which is a record height for the entire solar system. The atmosphere of Titan is quite clearly separated into several layers, composed of different substances, and very diverse in terms of temperature. While the temperature on the surface is negative 290 Fahrenheit, at the height of 200 miles it's much warmer, only negative 130 Fahrenheit. At the very top, the Titan sky turns blue as it's filled primarily with nitrogen and hydrogen, but at the height of about 250 miles, the aforementioned orange haze begins to form, which continues all the way down to 60 miles, only clearing as you approach the surface. At the height of about 30 miles, the surface of the satellite becomes visible. To many people, it will look quite familiar as the landscape includes mountains and rivers. During the landing of the Huygens, it was discovered the orange haze layer is fairly evenly opaque all the way through. Here, the sunlight never really reaches the surface. This is what a sunny day on Titan looks like at noon. While the surface has texture, it's still relatively flat, with the highest parts of the land only rising as high as 0.6 miles. Take a look at this first image taken by Huygens upon landing. It's likely that the spacecraft landed in a dried-up bed of a methane river, leaving behind some smooth ice rocks that look like pebbles. They will have been preserved since the time the river was still full of liquid methane. That was pretty strange. There were no traces of liquid. Where did the supposed methane rivers go? After the images from the landing were processed, a few of them were combined into this collage. Here you can see an image of a river system with many streams branching off, not too dissimilar to some of the places on Earth. This prompted several theories as to where the liquid could have disappeared. The first theory sounds pretty earthly. As Titan undergoes the changes of the climate cycle, these rivers are filled with methane rain, and afterwards they dry up again. The second theory put forward by the scientists was that these methane rivers drew liquid methane from underground springs, which no longer function for some reason. Next, the Cassini probe will collect more data over the course of 127 flyby missions in Titan's orbit. For starters, thanks to this photo of the atmosphere taken by Cassini, we could begin to decipher the reasons why Titan's atmosphere is so opaque. Thing is, it's made up of multiple layers. The first layer is basically the biggest factory, producing complex organic compounds in the solar system. Right there at the height of over 300 miles, methane, nitrogen, and hydrogen are exposed to sunlight and transformed into more complex elements, which then begin to descend towards the surface, creating a new layer. The second layer is situated between 200 and 250 miles away from the surface and is made up of a tholin haze. An example of tholins on Earth is soot produced as a result of a combustion process. The third layer starts at around 200 miles. It consists of the inert gas ethane. Here, scientists noted a unique anti-greenhouse effect. On Earth, gases in the atmosphere trap heat and warm up our surface, resulting in the greenhouse effect. On Titan, tholin haze and ethane create the opposite effect, essentially forming a shield and maintaining both the heat from the sun at an altitude of 250 miles and the cold temperatures of negative 290 Fahrenheit degrees near the surface. At the height of approximately 60 miles, Titan even has some clouds, though very few. And although the climate on Titan changes very quickly compared to Earth, very recently there was a real tropical methane storm recorded around the equator of this moon. Take a look at the way it looked from Cassini. Thanks to its unusual shape, this storm was nicknamed the Arrow. It spread across an area of 200,000 square miles. The methane rain that was falling from the sky during the storm looked very unique compared to the rains we have on Earth. Imagine raindrops the size of a pear descending so slowly you could easily dodge them. Huygens and Cassini were able to confirm the composition of the atmosphere. Similar to Earth, the atmosphere on Titan is mostly nitrogen. However, it also contains 3.5% methane. But that wasn't the interesting part. On Earth and many other planets, the chemical processes take place near the surface. On Titan, however, its chemical reactor is located at the altitude of 300 miles, which results in huge amounts of organic compounds descending to the surface. Over 4.5 billion years ago, Earth was exactly the same. The only difference being that Earth was warmer due to its proximity to the sun both then and now, and the organic substances that fell from the sky did not fall into the methane soot surface and liquid methane, but into the oceans full of water. After studying the composition of the atmosphere and its layers, scientists came face to face with yet another mystery. It's been calculated that the methane that is now in the atmosphere should have disappeared 10 million years after the formation of this atmosphere, and yet it did not. Something continues to fill the atmosphere with methane, maintaining its level for more than 4.5 billion years. Some scientists have suggested that in the process of Titan's formation, there was so much methane that the supply has not dried up to this day. Others have suggested that methane is produced by some type of chemical processes taking place on the surface, and even that there are organisms that produce methane as part of their life cycle. This was the first hint of potential, albeit primitive, life on Titan. The second mystery for the scientists was the amount of hydrogen in the atmosphere. There's supposed to be 2.5 times less. It wasn't clear where so much of it comes from and why it's so unevenly distributed. At the surface level, there is less hydrogen than there should be, in contrast to the hydrogen content closer to the top, of which there is twice as much as there should be. This led the scientists to think about biological processes that may be using hydrogen that descends to the surface, creating a shortage. Leaving these questions unanswered, let's turn our attention to the surface of the moon for a while. First, take a look at this photo taken using the VIMS camera. This is an approximation of what the surface would look like. This is an approximation of what the surface would look like to the human eye. Looks a lot like Earth, doesn't it? The following images make that resemblance even more pronounced. This topographic map, captured using a radar, once again creates a sense of déjà vu when we compare it to Earth. It should be noted that there are very few craters created by meteorite impacts on Titan. The largest of those, the Minerva crater, spans 500 miles in diameter. The absence of craters can be explained by the extremely dense atmosphere, where anything small simply burns out. However, in these circumstances, these are still too few. This poses a problem for scientists researching the surface. It significantly reduces the chances of figuring out the age of the relief. As a result, scientists cannot say for certain how geologically active Titan is and whether it has a system of tectonic plates like Earth. In fact, its surface is suspiciously smooth. Let's take a look at Titan without the atmosphere to pinpoint our next point of interest. Initially, the dark areas that you see aroused a lot of interest in scientific circles. The scientists theorized that that's where the methane oceans were located. However, when Huygens landed in that exact area, it didn't find any liquid. Upon closer examination, it turns out these dark spots are deserts. When they were compared against Earth deserts, it became clear they are extremely similar and formed as a result of the same processes as on Earth. Due to the climate system operating on Titan, with its own seasons and wind patterns, a dune system composed of tholin soot and organic substances was formed. Except on Titan, due to low gravity, a wind of 11 miles per hour is enough to start a dust storm. Although the sand on Titan is organic, unlike on Earth, the scientists are still searching for an answer as to what created it. Initially, it was assumed that this sand was created from the remnants of methane that falls from the sky when it rains, and since in its liquid form methane takes tholin soot from the atmosphere down to the surface, as the methane dries up, the particles left behind form this sand. But it rarely rains on Titan. So now the leading theory is that this sand simply falls out of the tholin haze directly onto the surface, kind of like snow covering the surface of the satellite. After studying the first pictures that showed the beds of dried up rivers, the scientists set about searching for the liquid, and the first methane lake, Ontario, was found at the south pole of Titan. It is the only remaining lake in that area. However, many dried up lakes have been found nearby. Scientists are still arguing what may be at the bottom of these lakes and what their shores are made of. Whereas at the North Pole, entire seas were soon discovered with rivers flowing into them. And although the Kraken Mare and the Ligeia Mare are unique objects in their own right within the solar system, as this is the only place where liquid has been found on the surface except for Earth. The main mystery is still the answer to the question of whether this satellite can sustain life. There are two approaches to consider. Based on the conditions we are accustomed to on Earth, we should pay attention to the following fact. Cryovolcanoes have been discovered on the surface of Titan, where liquid water bursts from the cracks in the surface, which means that under Titan's icy surface is an ocean of warm water. It does not come into contact with the core of the satellite and is sandwiched between two layers of ice crust above and below. However, thanks to the attraction from Saturn, it's obvious that ebbs and flows occur in it, which not only heat this ocean but also split the upper shell of ice. Water mixed with large amounts of acetone breaks out to the surface, and there it mixes with the same organic sand that falls from the sky. Together, this creates the same conditions on the surface of Titan that were on Earth 4.5 billion years ago. The only difference is that Titan is much further away from the Sun and significantly colder. That's why these processes are so fascinating to scientists. After all, they may lead us to understand in what conditions life appeared on Earth. We could call the other theory life according to Titan. It would seem that in such a cold environment and with such a huge amount of hydrocarbons without oxygen and water present, there's no life, and there could not possibly be. Indeed, the surface is basically a frozen gasoline lake. However, life is still possible, even in these conditions. Scientist Chris Mackin suggested that on Titan, the existence of methanogen bacteria is possible, just as it is on Earth. These bacteria feed on hydrogen and acetylene and live in this substance, producing methane as a result of that activity. This explains why there's so little hydrogen near the surface and why there's so much methane in the atmosphere, even though it should have evaporated a long time ago. It would seem that this could be the answer. And yet, a small problem remains. Methane and ethane do not act in the same way as water in regards to development of life. Water is an excellent solvent, which helps microorganisms get rid of waste and dissolve toxic substances. Methane and ethane in liquid and solid form are not suitable for work with the cell membrane, the part of the cell that performs the functions of filtration and protection. But more recently, Chinese scientists have managed to synthesize ozotosomes. These are organic compounds that could make up a protective membrane for a cell that lives in such an environment. And it's possible for this type of membrane to occur in methane and ethane on the surface of Titan. Additionally, observation through ALMA telescopes in the Mexican desert revealed that there is a substance from which the ozotosomes that would protect a living cell on Titan can be created, and in such quantities that could host up to a quintillion of such organisms within 10 square feet. Any other attempts to deny the possibility of life in a methane environment were shut down by the discovery of an unusual asphalt lake on Earth. It's composed almost entirely of natural asphalt, petroleum, and many complex hydrocarbon compounds. Samples taken from it showed millions of live anaerobic bacteria. Granted, these bacteria were incredibly ancient, but living perfectly fine in such an environment on Earth. Moreover, these bacteria feed on hydrocarbons and break down crude oil. Although the temperature regime on Titan is much lower than Earth's, and the chemical processes are slow and atypical for our planet, life on the satellite is possible and may even be pretty diverse, not dissimilar to life that originated on Earth 4.5 billion years ago. The kind of life we can even imagine. After all, it can exist both on the surface and under the ice in a warm ocean of water. All that we and scientists can do is wait for the next trip to Titan in order to get closer to unraveling the mystery of how life is born. But even now, you, just like thousands of other enthusiasts, can look through telescopes with keen interest studying Titan, a cold but living mirror of the Earth's past.